In this video, we will discuss piecewise defined curves. Piecewise defined curves are very commonly encountered in Calculus 1, especially with problems dealing with limits and continuity. Additionally, sketching piecewise curves is something that students typically struggle with. So let's look at a generic example. We would like to sketch the function which is given here. My first approach when I'm sketching a piecewise curve is to first take that x-axis and break it up in terms of which curve is sketched in which section of it. So when x is less than 0, we sketch y equals minus x. When x is equal to 0, we have just the output 2. So I'll go ahead and get that point in there. Between 0 and up to and including 2, we have the curve y equals x squared minus 1. And for 2 and beyond, we have the curve y equals minus 2. So now let's go ahead and sketch these. So for x less than 0, we have y equals minus x. So a line with slope minus 1 passing through the origin. But I'm going to include an open circle there because it's for x less than, not at 0. Now for y equals x squared minus 1, this is from 0 up to and including 2. So at 0, that function would be defined to be minus 1, but I'm going to put an open circle once again because it's not defined at 0. And then at 2, the output would be the number 3. So we get the following curve. And then for x larger than 2, we get the line y equals minus 2. Now, the most commonly encountered piecewise curve in calculus is most likely the absolute value curve. So let me remind you how we define the absolute value. It is a function where if we plug in a positive number, it remains positive, but if you plug in a negative number, it makes it positive. And we make a negative positive by multiplying by a negative. So it would be defined to be minus x when x is less than 0, and x when x is bigger than or equal to 0. And let's verify this graphically. I'll let each dash here represent 1 unit. So when x is less than 0, we're going to be sketching the curve y equals minus x. And when x is bigger than or equal to 0, we're going to be sketching the line y equals x. So y equals minus x, once again, slope minus 1 passes through the origin. And it's for x less than 0. Then when x is greater than or equal to 0, we have the line slope 1 passing through the origin. So that circle gets filled in. And we have verified that we do in fact get the graph of the absolute value function.